Let's go. Good day, everyone. I greet to Dr. Shakina and all our classmates. We are the students under the Faculty of Engineering, University Putra Malaysia, doing the project report for Engineering Maths 2. The title of our report is The Leakage at the Crude Acetic Acid Tank, and we are going to use the reduction to separable variable method to solve this problem. My name is Leong Zhen with metric number 202454.
My name is Wafa binti Azmi with matrix number 203125.
My name is Krishna. My metric number is 201734.
My name is Muhammad Ali Irfan bin Shamsuaidi. My matrix number is 200417.
All right, now without further ado, I will review the details of our problem. So now this figure shows the crude acetic acid tank of our company. This company had installed a storage tank to store their acetic acid. This storage tank has a volume of 6,000 meter cube and with a height of 15 meters and diameter of 22.6 meters. The parameters are shown together in the figures. However, after a few years of operating, the plant engineer noticed that there is a hole with 2 cm diameter at the bottom of the tank, causing a leakage. The height of the content is 5 meters when the hole is discovered. So our problem is, first, without the hole, how long will it take to fill the storage tank? In other words, the content must be dispatched at what rate? Secondly, what is the maximum allowable diameter of the hole to have zero effect to the volume? Third, is the volume inside the tank increasing or decreasing when the process is still going on? And the fourth question is, how long will it take for the fluid inside the tank to be empty when the process is stopped? So now, without further ado, I would like to invite my classmate, my team member to explain to us the solution.
So I will be presenting question 1. So for question 1, we have to take it into account the inflow rate, outflow rate, and V maximum. So the inflow rate was 4.8942 liter per second, and the outflow rate was 2.4471 liter per second. And the maximum volume the maximum capacity of that tank is 6,000 meter cube. So we can start off first by converting them into meter cube per day. So it might ease our calculation in the further calculation. So we can get these two values, and we all know that input minus output will be accumulation. So our input value 422.86 minus 211.43, we will get 211.43 meter cube per day. So that's our value for accumulated acetic acid. So next we will continue with our separation of variable. So dV by dt is equal to k. So integral of dV is equal to integral of k dt. So if we integrate dV, we will get v, and if we integrate k dt, we will get kt plus c. So when we substitute, our t is 0, v is 0, so we will get our c. So I'm saying this because at time 0, the tank will be the content of the tank will be 0. So our c will be 0. We will get our v will be kt. So at time is equal to 1, v is equal to 211.43. So our k will be 211.43. So as we know that the flow rate accumulated will be 211.43 meter cube per day. So one day the volume accumulated will be 211.43 meter cube. So we will get our equation as V is equal to 211.43 T. So the maximum volume of tank was given, so 6,000 meter cube. So 6,000 is equal to 211.43 T. So from that we can get our T is 28.38 days. So which is approximately equal to 4 weeks. So as the calculation shown, it takes every 4 weeks to be dispatched. So every 4 weeks we must dispatch it to avoid any bursting or any leakage. So that's it from me.
Thank you, Krishna. Now I would like to invite Wafa to review the solution for the second questions.
Okay, for second question, Leonson, can you please zoom for me?
Zoom in a little bit. Wait a second.
Okay, it's okay.
Okay.
Yes. Okay, so for the question number 2, the question is what is the maximum allowable diameter of the hole to have zero effect to the volume? So first, zero effect to the volume means dV dt is equal to 0. So dV dt is equal to input minus output and minus the consumption. The consumption is the leak. Okay, and then we calculate the input minus the output, and then we convert the unit to meter cube per second. 1 meter cube is equal to 1,000 liter, and then we get 2.4471 times 10 the power of negative 3 meter cube per second. And then we continue using we represent the leak using the Torricelli's law to solve this problem. Okay, so the volume is 0.6 power root of 2 gravity and height, and then the area, this is cylinder, so we use the area pi r square, and then we insert the value into the formula, which is input minus the output and minus the consumption equal to 0, and then we try to find the area value. From the area value, we use equal to pi r square to get the radius of the hole, and then we got 0.0115 meter is equal to 1.15 centimeter, and then we times 2 for the diameter, which is 2.30 centimeter. So when the diameter of the hole, so the diameter we got is 2.30 centimeter. So if when the diameter of the hole is equal to is smaller than 2.30 centimeter, the effect of the volume of the hole, the effect of the leaks to the volume is negligible. And however, if the hole is larger than 2.30 centimeter, in the meter, the maintenance needs to carry out immediately.
Right. Thank you,
That's all
Wafa. Thank you, Wafa. Now I would like to invite Alif to tell us the solution for question 3.
Okay, for my part, the question is the volume inside the tank is increasing or decreasing when the process is still going, which is leak? So based on the calculation on Wafa, which is in question 3, we can say that the volume inside the tank will increase. So why? This is because the diameter of the hole is less than 2.30 cm, which is 2 cm only. As Wafa has mentioned that when the diameter of the hole is less than 2.3, the effect of the leak to the volume is negligible. So what I mean that it is smaller than the maximum allowable diameter. Therefore, the volume will keep increasing. However, such error need to be repaired as soon as possible in order to prevent the catastrophic accidents.
All right.
Okay.
Thank you, Alif. All right, thank you, Alif. Now I will present the solution for the final question, which is when the process is stopped, how long will it take for the tank to be empty? So in order to solve this problem, we need to relate 3 equations First, delta V is equal to AV delta T. Secondly, delta V asterisk is equal to negative B delta H. And finally, V is equal to 0.6 square root 2 GH. The first equation relating the decrease in water level to the outflow. And the second equation relates the volume of the tank. And the last equation is the representative of Torricelli's law. By combining all the three equations, we will have negative B delta H equals to A bracket 0.6 square root 2 GH delta T. And then we will divide both sides by delta T. We will get delta dH dt is equals to negative A over B 0 multiplied with 0.6 square root delta H. And then by factoring out the delta H, and then we do the separation of variable, we will get integrate 1 over H equals to integrate negative A over B 0.6 square root 2G. And then we will do the integration and get our particular solution. By substituting the area of the hole and area of the tank, we will get the particular solution of our equation. And then finally, we substitute when T is 0, H equals to 5, we can get the general solution for our equation. And lastly, when the content is empty, it means that the height of the tank is equals to 0. So we will take our general solution and make the equation equals to 0 and then solve for T. And finally, after mathematical calculation, we get T is approximately equals to 24.89 days, which is 24 days and 21 hours. And finally, hereby we summarize the reference that we get to solve our problem, and we like to thanks to Dr. Shakina for viewing our videos, and also I would like to thanks to our teammates in helping me to solve the problem. So thank you everyone. And that is all about our presentation for the project report of Engineering Maths 2. Thank you everyone.
Thank you.